Okay, get ready to dive into some seriously mind-bending physics today.
Sounds fun.
Yeah, we're talking about something called the amplituhedron.
Okay.
And it's not just some random geometric shape, although it is that too.
Right.
It's like this crazy powerful tool that might just rewrite how we think about the entire universe.
Wow.
Yeah, no kidding. We'll be basing our deep dive on this really interesting educational article about the amplituhedron.
Awesome.
So get this, the amplituhedron is like this multidimensional shape that lives outside of our normal space and time.
I've heard bit about that.
But it somehow manages to describe how particles interact.
Huh. Interesting.
And get this, some physicists think it could be even more fundamental than space and time themselves.
Really?
Yeah, it's a wild idea.
It is.
But before we get too ahead of ourselves, let's start with the basics. So
Mhm.
can you kind of break down what this amplituhedron actually is?
Sure. So imagine you're trying to figure out what happens when two particles smash together, like in those giant experiments at the Large Hadron Collider.
Okay, I'm picturing it.
For a long time, physicists have used these things called Feynman diagrams to calculate those interactions.
Right, like a little roadmap for the particles.
Exactly. But the problem is, as you get to more complex interactions, you need tons and tons of these Feynman diagrams.
Well, I bet.
And the math gets ridiculously complicated, like trying to solve this massive puzzle with millions of tiny pieces.
Okay, so I'm guessing the amplituhedron comes in as some kind of physics puzzle solver.
You got it. Instead of crunching through all those complicated equations separately, the amplituhedron lets you visualize them as points on a multidimensional shape.
Hold on, multidimensional shape. My brain is already starting to hurt.
Well, think about it like this. A 3D object casts a 2D shadow, right?
Yeah.
So maybe this amplituhedron is like a shadow, but from some even higher dimensional space that we can't directly see.
Okay, so it's like finding a shortcut to solving a really hard math problem.
Exactly. It simplifies everything.
But what makes this shape, this amplituhedron, so special? I mean, there are lots of shapes out there.
Well, the crazy thing is that it doesn't exist in our normal understanding of space and time.
So it's not actually somewhere in the universe.
That's the mind-blowing part. It lives in this mathematical space with way more dimensions than we can imagine.
Okay, so where is it then?
That's the thing. We don't really know, and that's why some physicists think it might represent a deeper, more fundamental level of reality than space and time.
Whoa. Okay, my head is officially spinning. Are you saying this shape could change how we see the entire universe?
It's definitely a possibility, although it's important to remember that even the physicist who came up with the amplituhedron, Nima Arkani-Hamed, he says we shouldn't jump to conclusions too quickly.
So maybe hold off on rewriting physics textbooks just yet?
Yeah, for now, but it definitely hints at a deeper structure to the universe than we currently understand.
That's pretty wild.
It is.
Okay, let's go back to the amplituhedron for a sec. You mentioned earlier that it somehow encodes this idea of locality,
Right.
which is basically the idea that particles can only interact when they're in the same place.
Yeah, like you can only high-five someone if you're right next to them.
Exactly. But if this amplituhedron isn't in any particular place, how can it have this rule about things needing to be in the same place to interact?
That's a great question. It's like saying you can only high-five someone if you're standing next to them, but without actually having the concept of standing next to them.
It's like the rules of the game are built into the amplituhedron itself, even though it exists outside of our normal space and time.
Exactly. It suggests that locality might emerge from this deeper mathematical structure rather than being a fundamental property of space-time.
That's amazing. Okay, so aside from potentially turning our understanding of the universe upside down, are there any other uses for this thing?
Absolutely. One of the most exciting things is its potential to help us finally unify different areas of physics, especially quantum field theory and general relativity.
You mean like the holy grail of physics,
Hmm.
combining the super tiny with the super massive?
Exactly. See, physicists have been struggling for decades to describe gravity at the quantum level using traditional methods.
And it sounds like the amplituhedron might offer a way to do just that.
It could be a game changer. Now, early models of the amplituhedron, they were kind of limited to theoretical universes with something called supersymmetry.
Which, as far as we can tell, our universe doesn't actually have.
Right, but the exciting thing is that researchers are already figuring out how to adapt it to more realistic models.
So we're getting closer to something that can describe our universe.
Exactly. They're even starting to incorporate particles like pions, which are definitely part of our universe. So while there are still challenges, like figuring out how to incorporate gravity fully,
Yeah, that seems like a big one.
it is, but the progress is really encouraging.
It's incredible to think about this weird shape that exists outside of space and time could be the key to unlocking some of the biggest mysteries of the universe. Maybe it'll even lead us to that unified theory of physics everyone's been searching for.
It's definitely a possibility.
But even if it doesn't rewrite the laws of physics completely, it's already doing amazing things.
Like,
Well, it's simplifying these super complex calculations that used to take forever.
that's a big help.
And it's giving us a whole new way to think about the fundamental nature of reality.
I like the sound of that.
Me too. And honestly, it makes you wonder what other mathematical marvels might be out there just waiting to be discovered.
You never know what's hiding in the math.
Exactly. So for anyone listening out there, next time you see a weird shape, just think it could hold the secrets to the universe.
Now that's a thought.
Right.
Yeah.
So keep an eye out for those shapes, folks. You never know what you might find.